All right, moving on to 7.6 notes, where we'll be talking about the key features of functions. The objective for this lesson is that you should be able to identify the key features of a function. All right, so for the first task, we're going to read the definition for each term, and then we're going to use these definitions to identify the key features on this specific graph. So the first feature is X-intercept, and it's the point or points where the graph intersects the x-axis. So we can see where this graph definitely does that. So we need to make sure that we know exactly how to write the answer for what are the x-intercepts of a function. All right, so since the definition for an x-intercept is it's a point where the graph intersects the x-axis, we need to make sure that we write our answer as ordered pairs. All right, so the x-intercepts for this graph or this function are at -10, 0, -5, 0, the origin 0, 0, and 5, 0. The y-intercept is the point or points where the graph intersects the y-axis. So while there are 4 x-intercepts for this function's graph, there's only one y-intercept. Again, that's at the origin 0, 0. Now, when we talk about a function is increasing, that's when the value of the y increases as the value of x increases. So we need to write the interval of x values to identify where the function is increasing. So again, looking at the graph, we are trying to find what parts of this graph show an increase in the function. Again, as the x value increases, so does the y value. So as you can see from the graph, the parts that I highlighted, that's where the function is increasing. All right, so from left to right, as the x value increases, so does the y value. This is where, again, the function is increasing. So now, the way we write where the function is increasing, again, is using interval notation. So over what x values do these functions increase? So the first interval for that first section of the graph where the function is increasing is -8, -2 in parentheses. So now we need to be careful. We have to understand this is not an ordered pair, right? For x-intercepts and y-intercepts, the reason why we use parentheses there for those responses is because we're talking about points. And points are ordered pairs, which are using parentheses. But for functions where they're increasing or decreasing, the reason why we're using parentheses is because of interval notation. So again, looking at the graph, from an x value of -8 to an x value of -2, this is where the function is increasing. Okay, so again, the highlight, -8 to -2 along the x-axis, that's where this function is increasing. The next interval of where the function is increasing is from 0 to 2. So again, that's that middle section where the graph is going up from left to right. Again, we're using interval notation. Over what x values does this function increase in this section? It's going from 0 to 2 along the x-axis. The third interval for where this function is increasing is from 5, 10 along the x-axis, from 5 to the ordered pair. All right, this is at this is at ten, 10, 8. So from 5 to 10, this function is increasing. All right, so now we're looking for where the function is decreasing. So as the value of y decreases as x increases. So we're looking for those intervals or those parts of the graph. All right, so you can see this is the part of the graph where the function is decreasing, going down from left to right. All right, these are the parts where the function are decreasing. So let's see if you can write the interval over which this function decreases. All right, so over the interval negative infinity to negative 8, negative 2 to 0, and then from 2 to 5. These are the intervals in which the function is decreasing. All right, so next, when we talk about turning points, these turning points are the points on the graph where the graph changes direction. It either changes from an increase to a decrease or a decrease to an increase. All right, an absolute, or sometimes called a global maximum or minimum, that's the point where the function attains its largest or smallest value. All right, so we need to kind of amend this definition that's already pre-printed on your note sheet. All right, so where it says a point, we're going to add some words there. All right, so again, an absolute or global maximum or minimum is a point with respect to the x-axis where the function attains its largest or smallest value. So again, a point with respect to the x-axis where the function attains its largest or smallest value. So let's identify the global max and the global min. Now, this particular function does not have a global max. And the reason for that is because of this arrow. All right, so again, remember, arrows on a graph mean the graph goes on forever in the direction that it's pointing. And so because this arrow points in that direction, going up, that means there is no maximum. Right? There is no max. All right, but there is a min, a global minimum. So the lowest value that this graph goes with respect to the y-axis is right here. Right? So this is the lowest point, right, of this graph. So this is where a global min is going to be identified. All right, so while there's no global max, there is a global min. And the way we write that is it's a minimum of -4 and an x value equal to -8. So again, all you have to do is look at the ordered pair from which that point is associated. Right? The min of -4, -4 is the y value at that point, and an x value of -8. It's important that you write these accordingly. All right, a relative or local maximum is the points with respect to the x-axis of a function where it achieves a maximum value within its general area. They exist at the turning points where a graph is changing from increasing to decreasing. Okay, so let's identify the relative local max on this graph. All right, again, by definition, these are the 2 points on this graph where we have a relative or local max. All right, again, it's a turning point where it changes from an increase to a decrease. So this is where your local maximums are. And how to write that answer on a homework, quiz, or a test. There's a maximum of 6 at x equals -2 and a maximum of 10 at x equals 2. All right, moving on to the relative local minimum. Again, it's a point with respect to the x-axis of a function where it achieves a minimum value within its general area. They exist at the turning points where the graph changes from a decreasing to an increasing. All right, so going back to the graph, these are the points where you have a relative local minimum. All right, again, this is how you write those responses. Minimum of -4 at x equals -8, minimum of 0 at x equals 0, and minimum of 0 at x equals 5. This is the relative local minimum. All right, let's see what you can do with example number 2. Answer questions A through K regarding this function's graph. All right, so let's see how you did. So this is definitely a function because it passes the vertical line test. The domain of this relation with squared off brackets is -6, 6. The range in brackets, -2, 5. The x-intercepts, they're at -6, 0 and -2, 0. And the y-intercept is at 0, 5. Now the next few answers are dealing with intervals. Over what interval is the graph increasing? In parentheses, -4, 0. Where is the graph decreasing? Over the intervals of -6, -4, and 3, 6. Where is the graph constant? And there's no change between 0 and 3. And now for max and mins. The absolute maximum is a maximum of 5 over the interval of 0, 3. There's an absolute minimum value of -2 at x equals -4. The relative maximum is a maximum of 5 over the interval of 0, 3. And the relative minimum of -2 is at x equals -4. Okay, so let's really get a gauge of where you are in understanding this material. Let's see what you could do with example number 3. And then when you're done, go ahead and unpause the video and check your answers. All right, so for this function's graph, the domain exists from -infinity to +infinity, again because of the arrowheads. The range of this function is from 0 to +infinity. The x-intercept is at 3, 0. The y-intercept is at the ordered pair 0, 1.5. The intervals for which this function is increasing is from -1 to 1, and also from 3 to +infinity. The intervals for which this function is decreasing from -infinity to -1, and from 1 to 3 along the x-axis. There is no absolute maximum. However, the absolute minimum is a minimum of 0 at x equals -3, a maximum, a relative maximum of 2 at x equals 1, and 2 relative minimums. One minimum of 1 is at x equals -1, and another relative minimum value of 0 at x equals 3. All right, so that's it for today's lesson. Again, if you have any questions or need any extra help, please make sure to see me as soon as possible.